Welcome to Online Math. Today we will look at the area formula for kites and trapezium. To find the area of a kite, you need to use this formula. Area equals to 1/2 times the product of the length of the diagonals. So we now need to find out what the diagonals are so we can find the product of these diagonals and times it with 1/2. So looking at our kite here, where are the diagonals? We can draw the first one, the length x. So this is one diagonal, and the other one would be coming from the top to the bottom bit, and this would be the second one, and I'm going to call it y. So to rewrite our formula for the kite, I would say area is 1/2 times x times y, where x is one diagonal and y is the other one. And I'm timesing it because it's looking for a product and timesing with 1/2. So this is how you would find the area of a kite. To find the area of a trapezium, you first need to get the average length of the parallel sides and times that by the distance between the parallel lines. So where are these parallel sides or the parallel lines? With this trapezium here, we see the parallel lines right here. So you see the top bit and you see the bottom line, and there are parallel lines. So, to find the average length of these parallel sides, I'll give them a name. I'll call the top line A and the bottom bit B. So for the first bit, where it asks for the average length of parallel sides, I will go A plus B. And to find the average, I'm going to divide that by 2. Then I need to figure out the distance between the parallel lines. So what is the distance between A and B? The distance would be this part here, which I'm going to call it H. So times H. So this is how I would find the area of a trapezium. I would just grab the first bit, the top line A, and the bottom bit B, put it into a bracket, divide by 2, and then times it by height, or in other words, the distance between the parallel lines. Let's calculate the area of this kite. To calculate the area of a kite, we'll be using a formula A equals to 1/2 times the product of the length of the diagonals. In this case, I'm going to call my two diagonals x and y. So I'm going to write 1/2 times x times y. Now looking at the figure on the left, one diagonal is 8. And the other diagonal is 7. And it doesn't really matter what I call my x or the y, but I'm just going to call the 8 centimeters my x and the 7 centimeters my y, and I'll get the exact same answer even though I switched them around. So going back to my formula, area equals to 1/2 times where it says x, I'm going to put 8 centimeters, and where it says y, I'm going to put 7 centimeters and do my calculation. 1/2 times 8 times 7 is 56, so I'm going to do that bit first, and 1/2 of 56, or 56 divided by 2 is equal to 28. And don't forget, with your area questions where you are timesing centimeter by centimeter, you have to go centimeter squared. To calculate the area of a trapezium, I'll be using the formula area equals to the average length of the parallel sides. So the parallel sides I'll call A and B, so I will need to go A plus B over 2, and times by the distance between the parallel lines, which I will call height. So we're using this formula. So looking at the left-hand side, the figure given to us, what are my parallel sides? As you can see, this little marking here to show us that the line above where it says 7 and where it says 9, those are my parallel lines. So I'll just call the top bit A and my bottom bit B. And where is the height or the distance between the parallel lines? Here are my parallel lines, and so the distance between these two parallel lines would be 8 centimeters. So I'll call that H. And plug those numbers into our formula. So where it has the average length of the parallel sides, A plus B, instead of A, I'll be putting in 7. Instead of B, I'll be putting in 9. So 7 plus 9 over 2, close brackets, times by height of this trapezium, which is 8. And we just calculate. So 7 plus 9 is 16 over 2, close bracket, times 8. 16 over 2, or 16 divided by 2, is equal to 8, and times 8. And notice that we were using centimeters for our units, so it would be 8 centimeters times 8 centimeters. So altogether, the answer would be 8 times 8, 64 centimeters squared. Thanks for watching, and I will see you next time.